The point is to be efficient, and
Right.
an efficient index is created only when we exactly know what happens.
Hello, everyone, and welcome to this episode of the Unofficial Ignition Podcast. My name is Jonas, and today I'm joined by Dragana. Dragana is a data expert at Inuda. And what is your main specialty?
Well, in Anuda, I mainly work with databases.
Cool. And is that what we're gonna talk about today? What's the main scoop of this interview? I should know. I'm
Exactly.
interviewing you, but
Exactly. We're talking about indexing in databases.
and what is indexing? How would you describe it so everyone, and especially me, can understand this?
Well, by definition, a database index is data structure that allows a query to efficiently return the results from the database. And what does that mean? Well, let's consider the index that is in back of each book. It is so simple to use. We just scan for the subject or the topic that we are interested in. We note it and flip to those pages in the book. And in this example, the key for the index will be the subject words we reference. And because the keys are in alphabetical order, that makes it much easier for us to scan the index and find an entry. And if we consider an alternative, a book without an index, in worst case, which is, let's say, if the topic that we are interested in is on the last page of the book, we will need to go through the entire book and flip every single page in the book. So, practically speaking, the index would save us a lot of time. And the same thing applies in database indexes. We use it to improve the performance.
Right. So all this is only done when you're like have such a big amount of data that you kind of lose the bigger picture, so to say. Is that
Well,
correct?
mostly it depends when we actually create the database indexes. But the most important thing is to know what to index and how indexing is going to boost the query response time. And for example, a proper index can be done only when we know exactly what the data access patterns look like. And if we say at the very beginning, we know which data will be accessed the most or which queries will be used the most, then we can create the obvious indexes from the very start. But as time goes and as the database gets larger and larger, we may find ourselves in a place where improvement of performance is needed, and then we can maybe more clearly see which indexes are not running efficiently or which indexes can be additionally added. So mainly it depends, but nothing stops us from creating indexes, dropping indexes, playing around, and even doing that during the performance tuning.
Right. So this work happens into a project. We don't do it to begin with normally. Is that right?
Well, every project uses, or mainly every project uses a database. So, and the most important part that the users see is the response time, or the time that they see the results.
Right.
And here comes the indexing, how we can reduce the response time and improve the performance.
But can you can have a database without doing indexing, right?
Yes, exactly.
So how much data do we need before this becomes relevant?
Well, as the database gets larger and larger, meaning when the database has more and more data, it is easily to see the benefits from indexing.
Right. So, but is it do we usually do indexing on a project, or is it something that's reserved for like the bigger ones, the special projects that grow in size? Or is this just common practice that we kind of need to do no matter what data sets we work with?
Well, as I said, if at the very beginning we know which data we will be using, or what is the limit of the data, how much the data will grow with a time, then we can create the obvious indexes at the beginning and maybe delete some of them if they are not running efficiently, so nothing stops us from creating them whenever we want. But the obvious indexes should be created at the very beginning.
And what kind of improvement are we talking about? Is it milliseconds or seconds, or how much better can we make a slow and bad database?
Well, everything depends of the data, of the queries.
Right.
But it can go into seconds, of course.
Okay, so you can have you can wait several seconds on something, and then when you improve the structure of the database, it can be almost instantaneously.
Exactly.
Okay, so it does. We do come to a point where it's not just annoying. It can be impossible to work with a data set if you don't have indexing.
Exactly. Yeah. And
okay.
That's where indexes come, and that's the whole point and reason why we use indexing.
Right. Cool. Can we? Do you have an example? It's still a little abstract for me.
Sure. Let's see an example.
Excellent.
So first, before giving an actual example, I will try more to explain of a structure of an index. So the structure of the index is the reason why improvement of the performance is possible. So this is a single index, and each index is based on a table. This index, for example, contains two columns. The first column is called a search key, or only a key, and then we have the second column, which is called data reference, and we also call it value. So the first column, which is called the search key, contains a copy of the key used for indexing for the concrete table. And these values are always sorted in an order that allows the quick access. And the second column, which is called data reference value, or we even call it a pointer, has a set of pointers holding the address where the key value can be found. Now I will show an example of that. Okay, so I will show an example of indexing. I will use a simple database design which contains data for air pollution. And first I will run a query which uses a table that contains 4 million rows. And in this example, we will not use any indexes and see what happens. Let me explain a little bit about this query. So in this line, we have the where clause, which specifies the search condition. And when we use query which does not have any indexes, the database needs to scan the whole table, indexes, and in this example the measurement table, and check every single row of the table and see if that concrete row meets the given requirements, which in this case are in the where clause.
Right, so that's just brute forcing result.
Yes, exactly. Then we have the order by part, and as the name says, we'll see the results in an order, first sorted by time and then sorted by average value. And if we do not have a relevant index for the order by part, the database will need to run a sort operation which takes a lot of time. Now I will run the query and we'll see what happens.
It's taking its time.
Yes, because we're not using indexes. So here we get an execution plan. So this execution plan contains every operation that the database needs to run in order that we get the results. And here we see that the database runs a sort operation. And in the last line, we see the execution time. We see that it took more than 5 seconds.
Right.
Now I will
Which is
create
not what you want when you're sitting there waiting for your
Exactly. Yes,
data.
exactly. Now we will create an index. I will name it example index, and we will create it on the table measurement, which we use this query. And first, in this index, I'll need to include every column that is specified in the where clause. So in this case, we need to add just the time column, and then we add all the columns that are in the order by part. And because we already have the time column, because of the where clause, we only add the average value. Now I will create the index. And this index is actually a 2-column index, and I can compare it with a telephone directory where all the data is first, as we know, sorted by the surname and then by the name. And we know that because it is first sorted by surname, we cannot directly search by name. So the same applies for the database index. So ordering of the columns in the index is very important.
Right.
Now we have our index, and we can run the query again. And now we get the result. And the
Way
first
faster.
thing that we can see is that there is less operation than that the database successfully emitted the sort operation. And lastly, and most important, the execution time is reduced a lot.
Yeah. Yeah, that's quite significant. And is this, I can imagine when you have a big database that these classes and categorizations of data becomes pretty complex.
Yes, exactly.
How, yeah, is it, who's responsible for keeping, keeping everything in check and knowing where everything fits? Doesn't it get messy?
Well, the database knows everything, so
Right.
it's easier. Yeah.
So this method only works if you have a clean data set. If you know where to look in the different indexes. Is that correct? Or can you clean it up while doing this? Is that what's happening?
Well, if we want to use indexes, we need to know exactly what our data look like.
Yeah.
So in order that we create the indexes efficiently, we can create indexes whatever we like it, but the point is to be efficient, and
Right.
an efficient index is created only when we exactly know what happens.
Right. That makes a lot of sense. So you need to know what you have before you can actually sort it out.
Yeah.
Or improve the performance of, yeah.
Exactly.
Cool. Excellent. That's super cool. Where does all this data you just presented, where does that come from? Is it just something you found? Or?
Yes, well, there is many data available online, so yes, this particular data is for air pollution, and it's available online.
Do you know how big the data set is? Like how many entries do we have?
Well, for this particular table, the measurement table, we're using more than 4 million rows.
More than 4 million?
Yes.
Okay, cool. Is that, I actually don't know what that is. Is that a big data set or is that a small data? Is it, where on the scale does that fall?
Well, it is a big, yes.
Okay. 4 million entries is a big data set. Cool. How many the work you've done the past 4 months? How many like data entries have you worked with in a set? What's normal for the
Well,
work
I've
we do?
worked with 20 million rows.
So a lot bigger than these. Okay.
Yes.
Cool. Excellent. Well, that clears up a lot of things for me. Do you have anything to add yourself?
That would be it.
That's it. Well, it sounds great. Thank you for being on the podcast, Dragana.
Thank you.
All
Thank
right.
you.
I'll see you.
Bye.
Bye.